I always remember right afterwards. Okay, hello. We have B.Jacobson with us tonight. He's an environmental engineer. He has a 40-year career in directing and authoring important studies to solve complex environmental water challenges to optimize mitigation. His clients come from both the private and the public sector. And locally, he has done work in the Comite, Manchac, and Amite River. And I'll add a little side note, Bob, you have a couple of people from the Lafayette area and Monroe with us also today. And also, you might have gotten the link. He has produced a series of informative videos on flood risk, which are useful to both professionals and interested laypersons if you had a chance to watch any of those ahead of time. So, Bob, I'm turning it over to you. Thank you for being with us tonight.
Great. It's a pleasure to be with some of my fellow naturalists. What I'm going to do today is kind of highlight a few slides on those videos. There's a total of 8 of them. They range from around 5 to a little over 10 minutes each. They're on the YouTube. I apologize for the quality of the narration. I don't have a professional studio, so I did the best I could with an iPhone to record a narration on them. What I'm going to do is give you a little background from where my profession of hydrology, and I've worked in the field, as she alluded, for a number of years. First in environmental and coastal, and most recently with a lot more intensity on flood hydrology. I'm fixing to take that glide path into retirement myself, but I want to share with you guys, and this is what I've been doing for the last several years, is what's happening in the state of the practice for our practice profession of flood hydrology. There's some very exciting revolutionary things that are coming. One of them, some of you might have actually seen in terms of risk rating 2.0 and FEMA. That's the tip of the iceberg of changes. Some of them are being done well, some of them aren't, and we'll get into that. This all relates to flood risk, and when I use the word risk, I'm putting a $sign on the S to connote that what we're talking about is the financial side of flood risk. Fortunately, in the last 20 years, we've seen tremendous advances at the National Weather Services and NOAA and the National Hurricane Center that are greatly reducing the risk to life and public safety. They're not zero, and obviously we do have tragedies of life loss and people getting hurt in floods. But by and large, my profession is focused on the dollar aspect of it, and that's not to diminish things like PTSD and things that aren't priced. It's just that what we're going to focus on today is the price aspect of risk, the financial aspect of risk, or what you'll see is the risk with the $sign. I'm going to highlight a few things from each of the videos, try to take up no more than about 30 minutes or so with the presentation so we can have plenty of time for different types of questions. So you're not going to see me touch on every one of these slides. As I said, the videos will have a full narration. Don't expect to kind of get what's on each slide, just kind of know that it's there, and then you can go back and watch that particular video to get into the details of it. This first presentation, and I'm not going to play the show because it will go into the narration, I don't want to do that, is just an introduction, has a few highlights about my background, shows some of the reports I've done all over Louisiana. This first one was my first one that I did back in the early 80s in Cenla for the Comanche Delta Regional Planning Commission. Stuff in New Orleans on the MRGO, as Janie alluded to, on the Comite River, surge studies for Slipway East down in the New Orleans area, and then more recently in the Amite River. One of my mentors was George Hudson, who recently retired, fine hydrologist. And so these are the sections of the video. They refer to the tenets, the 5 tenets of what I call 21st century flood risk wisdom, and we'll touch on each of those briefly. I'm not going to spend so much time on the 6th one, which is why I think this is revolutionary right now. A lot of this has to do with everything that we're dealing with. What we're doing now is a Zoom meeting. Technology is making things possible that weren't possible 10 years ago, including in being able to make better flood risk decisions, both personally and privately, in terms of our own risk and in terms of public mitigation. And so I'll touch real quickly on that. There are some changes going on in the area of government for policies for flood risk management. Let me close this one out and pick up the next one. Let me know if there's any problem with the screen not picking these up.
The first, most basic tenet of flood risk wisdom is actually very old. It probably goes all the way back to when humans were looking for that optimal.
Well, it didn't do what I think it was going to do. I wanted to open it.
Maybe if you go to the program, go to the file and start slideshow.
There we go. Are you seeing my screen now?
No, it's blank.
Okay, we got to go back to share screen again.
It's like you started a new PowerPoint.
Yeah, let me go back and share screen all over again. Let me do it. There we go. How's that?
That is good. If you go to the top and go slideshow and do start slideshow, it'll go full screen for us.
Yeah, if I do that, it's going to play the narration, which I don't want to do.
Never mind, you're in charge.
So I'm just going to show you the slides. The first tenet is that comes from real estate. Location, location, location. You can just see from this aerial shot of this one subdivision, different folks got hit differently by the same flood level. So this is a real key, is understanding that you and everybody needs to understand what their property specific flood exposure is. And the hazard and risk comes from knowing what your specific hazard is. There's several aspects to that to understand, one of which is that we do have 4 types of flooding in Louisiana. And some homes are exposed to all 4 types. And some homes are exposed to more than one source of a particular type. So a lot of people don't realize that FEMA flood maps don't do a really good job of identifying flash flood risk. I have a friend in the neighborhood around the corner in a neighborhood whose house flooded, and they've been in it for the proverbial, oh, I've lived here for 20 years and it's never flooded. Well, there was enough rain one day for the neighbors' yards to all drain to theirs, and because of the freeze back in the spring, the ditches hadn't been cleaned out, and guess what? Their house flooded for the first time from basically a 1 to 2 hour downpour. So flash flooding, obviously we're familiar with it in terms of when we drive around, but it is a major source of flooding, and sometimes it's not documented. So you could have just about any home where it rains has a flash flood exposure. If you're on a turtleback lot and there's no way your patio is ever going to flood into your back door, well, I guess you could say your flood exposure is very, 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 very small. But just about everybody should consider that they do have exposure to flash flood risk. River flood or downstream, or what we call a flood wave, that rain falls in the upper part of the basin, particularly if it's steeper and it comes downstream and floods someplace a day or two later. That's sort of the common river flooding that we understand. Over in the Lafayette Acadian area, of course, you have the Vermilion River flooding that was experienced during the 2016 flood that we experienced it on the Amite River. Backwater flooding happens, of course, when you have a sluggish part of the stream or river that begins to flood, and the other tributaries that are trying to get into that sluggish streams can't get in, and they start to slow down and rise, and the water comes up because it's got no place to go. Or in some extreme cases, the water actually starts to flow backwards. So that's backwater flooding, which a lot of our low areas of the state experience. Sometimes it happens just because of wind and tide. In low areas near the coast, the tide gets high and you get a river flood, and the river can't drain into backwaters because the coast is high. And then, of course, coastal flooding itself from tides and storm surge. It's important to understand how we talk about flood exposure in terms of magnitude. As hydrologists, we tend to focus almost all the time on the term elevation, which is in reference to a datum or a reference. Usually nowadays, we almost always use the national reference, which is called, sounds very technical, but it's just an acronym, NAVD 88. It refers to a particular datum. You could think of it like mean sea level, although it's not exactly, but it's so close you could think of it like mean sea level. And so when we say some place has an elevation of 10 feet, NAVD 88, that means it's pretty close to being 10 feet above mean sea level. Someplace that's 20 feet above NABD 88 is 20 feet above mean sea level. Those two places obviously then have a difference of 10 feet, but we use that as a reference that we can use everywhere. A lot of you will talk about flood height, which is a term above the local ground. So it depends on what the local ground is. You could have the same elevation, but the height might be different because the ground topography is different. And then flood depth, a lot of us use that interchangeably with flood height, but in a lot of particular instances, we're talking about flood depth, we're referring to the interior of a building. So it refers to the level above the threshold at which the building might receive damage, a concrete floor or a joist. So it's important to understand what your exposure is in terms of those things, because with an obstruction like the I-12 barrier, you could have big elevation changes in flooding over short distances. With topographic variations, like in this middle picture, you can have variations of flood height over short distances. And with building elevation differences, you could have differences in flood depth exposure. So not only flood types, but these variations in elevation, height, and depth affect your exposure to flooding over very short distances. You need to understand that flood exposure needs to be understood location specific, and it should be evaluated for each individual property. So anybody with flood exposure, which could be an owner, a renter, a banker, an investor in property, could be a building manager, all kinds of folks need to understand this critical aspect of flood exposure. I'm going to do this again. I'm going to close this one out and bring up another one. And I'll have to go through the screen sharing again. And it'll just take me a second. Next one has a lot of slides to it. It's Tenet 2 on flood hazard. And so there's some technical jargon in it. Again, don't get too hung up. What we'll do is I'll go over a few things, and then if there's somebody who really wants to dig into a question, we can do that. But what we probably want to do is go through the video to really see and understand most of the jargon.
As we just saw, the first basic tenet of 21st century flood risk wisdom that.
So there we go. So this one is flood hazard is a curve. Hello? Everybody hear me?
Yes.
Yep.
Good.
Yep, you're good, Bob.
Good. Flood hazard is a curve. Now, for the last 50 years, ever since the National Flood Insurance Program came around, we tended to talk about flood hazard as if it's a single value, the 100-year flood. And if it's a single value, then there's a single floodplain called the 100-year floodplain. Really, that's a ceiling level that's been developed and managed as an art over years. It's become considered a ceiling, and I call it an artificial ceiling. And what it does is it leads to a false binary perception of flood hazard, that there is hazard or no hazard. There's a map, you're on one side of the line, you're good, you're on the other side of the line, you're bad. Or if it's an elevation, you're above that level, you have no risk, you're below that level, you have risk. That is a false binary. A lot of things in life are well managed by thinking them of as binary, but flood hazard and flood risk, thinking of that as binary is a real problem. And it's a big part of the problem has been, and it's not an evil thing, it's just an obsolete thing that the federal government has never fully modernized the flood insurance program to reflect how we deal with other hazards, that there are shades of hazard. And the way we mathematically talk about that as hydrologists is that flood hazard is really a curve. So we do not want to think of flood hazard or flood risk as a binary. And without getting into a lot of the mechanics of it, this is a typical flood hazard curve. And in the mathematics of it, those of you who are a little mathematically inclined may notice that we have what's called a logarithmic scale here. And we have things called probability or annual exceedance probability on the bottom, which can be translated into something called a return period. When we talk about flood hazard and stuff, we're talking probability. And if you spend any time at the casino and studying Gambling. That's where people first figured out several hundred years ago what the science of probability was, is when they started liking to gamble and wanted to figure out how to win, or when the house wanted to figure out how to make money. Basically, it's an issue of frequency. If a particular flood level might be reached 5 times in 1,000 years, if you had 1,000 years worth of records, 5 in 1,000 is once every 200, and so that's a frequency. And it's just that's what probability represents. It's like, how often would you expect to roll 7 with a pair of dice? There's a probability associated with that based on the number of possible outcomes and how many ways there are to hit a 7. Well, with flood frequency, it's about how many times over a long period of time you might expect to reach a particular level. And that's just a frequency number. The way we tend to do it, though, in order to make decisions about flooding, is we simplify several things. One of the things we simplify is we assume every year you have the same probability for any randomness of flooding. Just like every time you flip a coin, unless it's a biased coin, you would assume you have the same probability. Or every time you roll the dice, the probabilities don't change unless the dice are loaded or something like that. Well, we don't expect Mother Nature to be loaded in theory. So we say you have the same probabilities for various flood levels year in and year out. Actually, we know with El Nino and La Nina and other climatological factors that you don't have the same probabilities every year. There are cycles. But we don't, at this point, in order to simplify things to talk about hazard, we basically assume that the randomness of flooding is year in and year out. So really a 500-year flood is just one that might occur 2 times in 1,000 years or 10 times in 5,000 years if you had a record for flooding. Obviously, we don't have those records. So what hydrologists do is they develop models and other techniques in order to estimate a hypothetically long period of time, how often different floods might occur. And from that hypothetical record, they extrapolate what they think would be the once in every 500 year, once in every 100 year, once in every 50, once in every 10, those kinds of numbers flooding. And then we draw a graph like this, and to squeeze all of those probabilities on the x-axis, we use something called a logarithmic scale, which I won't get into. But here's once every 10,000 years, or if you convert that to a decimal percent or a percent form, it's 0.01%. Here's the once every 100 year, or 1%, and here's the once a year, or typically a level that you could expect to be exceeded every year. Okay, so this represents what we call the curve, and it's kind of S-shaped, so we call these S-shaped curves. And that's how hydrologists for many, many decades have really presented hazard. The problem is that policy-wise, it's been oversimplified to think about it as just this one number. It's an intermediate level of flood. And I'm going to tell you in a few minutes and show you why it's really not that extreme of a flood level. It was a convenient number in the 1960s when they were designing the flood insurance program, because there was no mapping, there was no widespread communication nationwide for all the rivers and streams and lakes and coastal areas about what flood hazard would look like. They had no prospects of being able to generate a curve like this everywhere for every home across the country. So they said, let's just create a map and show at least where this one hazard level is. It made some sense at the time, but as I'm going to tell you, it distorts the perception of flood hazard when you think of that as being a ceiling, and it's not. And it should have been modernized many years ago to actually be able to provide everybody with what this curve looks like in their area, so that you can appreciate that you have these hazard levels and various magnitudes of flooding associated with different hazard levels. One of the key things about flood hazards, and this is the dirty secret of my profession that oftentimes you won't hear people confess to, and nowadays with other areas like epidemiology, and you guys are naturalists, so you appreciate this if you've looked at any statistics related to Mother Nature, is there's quite a bit of uncertainty in trying to pin down what Mother Nature's doing. And in terms of flood frequency, I mentioned one simplifying assumption, and that is that every year you have the same random probabilities of occurrence. There's other uncertainties. We just don't have these long enough records to really know what would happen once every 500 years, or really, in order to say what happens once every 500 years, you really need about 5,000 years worth of data to see what happens 10 times in 5,000 years. Then you have a pretty good idea of what a once in a 500-year event would look like if you had 5 events in 5,000, 10 events in 5,000 years. So 10 events in 5,000 years, those top 10 events would reflect what you would expect to say happens once every 500 years. We just don't have that kind of data. So when we're using these other methods to try to create a hypothetical record to try to figure out what that number looks like, these numbers start to have a lot of uncertainty. And as I said, one of the things our profession doesn't always do a great job of letting you know is that these uncertainties, and I showed that kind of with this cloud here, can be pretty big. And so I often jokingly refer to a lot of these estimates as scientific guesstimates. And there's a lot of things in science that we all appreciate, especially in this day and age with COVID and everything, that our scientists work very hard to give us their best recommendations and estimates on things, but they come with what we call error bars or uncertainty bars, which is a fact of science. And science doesn't always provide exact answers. And it's important to appreciate the level of uncertainty. Doesn't mean it's useless. It doesn't mean, comparing the 100-year level from one area to the other, that's not important. It just means that knowing what the precise 100-year elevation or 1,000-year flood or 10-year flood at any location precisely, that's not something that we can actually tell you most of the time. Even if we have gauge data, like at Grand Isle, which is one of the most significant places around Louisiana where we have a long-term record, probably, getting close to 70 years worth of data now. There's tremendous uncertainty at that location with what a 100-year flood elevation looks like. Could be so much uncertainty that it's not unreasonable to think that whatever we might look at the math and say, we think the 100-year elevation is about 7 feet, we could be off, and that could really be the 50-year elevation. That's the kind of uncertainty we have with these estimates. And when you talk about most flooding that's driven by rainfall, a good friend of mine is the state climatologist, Barry Kine. We talk about the uncertainty even in the rainfall numbers. And in a lot of places, we have data going back 100 years for rainfall, but 100 years isn't 5,000 years. And generally, I'm not even introducing the actual variables of climate change and landscape changes that can be actually changing flooding conditions and rain conditions. Just assuming nothing else was changing, even with no climate change and no landscaping changes, we have lots of uncertainty. Still, that, as I said, that doesn't mean that we shouldn't think that we can't use quantified estimates of flood hazard. We can and we need to, because we need to understand relative risk and relative hazard. We may not precisely know it here and precisely know it here, but we have a gauge that it's a lot higher here than it is here, and we can know where to make investments in mitigation. But it is important for everybody to understand that at specific locations, some of these estimates have lots of uncertainty. One of the factors that should be appreciated about estimates of flood hazard is that when I refer to frequency, and specifically when we convert it to a percentage number, like a 1% chance per year, or 1% is equal to 1 over 100. Again, that 100, when we use the word return period, a lot of people think we're talking about a cycle, and that a flood comes once every 100 years, like the earth revolves around the sun and makes it complete in 365 days. Christmas comes every 365 days. A flood comes every 100 years if it's 100. It's not a cycle. It's the denominator in that frequency. And go back to the assumption that we make that you have the same probability every year. You have the same chance every year of having a 1% chance. That's the 1% chance that year. You don't have the chance of 100% one year and then 99 years have a 0% chance. So people who get confused by the 100 years, a lot of people say we shouldn't use the return period of 100 years. I like it because it gives, again, a relative magnitude. The 100-year flood is rarer than the 10-year flood. But it is confusing to some people to say 100-year flood and not mean that it's not going to come for another 100 years. You can have, just like with dice, you can roll snake eyes twice in a row. I mean, you get a Superdome full of people, all hand them a pair of dice, and you'll have a lot of people. Tell them to make 2 rolls, a Superdome full of people. Well, there are going to be a lot of people that are going to roll snake eyes twice in a row. So it just depends on how many chances you go through, and it'll happen. So people can have 100-year floods 2 years in a row. No problem whatsoever. It is not a cycle. And I criticize some of my friends in the news media who interview people all the time after a flood and say, oh my God, it's never flooded here before. Like that's relevant. It's not relevant. You wouldn't interview somebody who just had their house burned down and said, oh my God, my house never caught fire before. It's not relevant. I mean, it's dramatic and it makes good TV, but it's not relevant. When we talk about extreme events, they have a probability. One of the important things about these probabilities to understand is when we talk about a 100-year return at a specific location, it sounds very rare. But when we really start thinking about it, you buy a 30-year mortgage, some of you probably heard about this. You buy a 30-year mortgage, you're taking that 1% chance 30 times. So now all of a sudden, it's not my chance is 1%. It is if you're only going to buy a house and live in it for 1 year and leave and then sell it. Yeah, your exposure duration there is 1 year, so your chance is 1%. If you buy a house for 30 years, or if you go back and look at a piece of property that's been in a family for generations, the exposure period is much, much longer. And it's like rolling those dice over and over and over again. When we talk about these long-term exposures, you have what we call cumulative probabilities. So the cumulative probability can get really high. For a 30-year mortgage, it's better than a 1 in 4 chance that what you thought was a level for a 1% flood in 1 year, the 100-year return period flood, that 1% chance flood elevation over the course of 30-year mortgage has better than a 1 in 4 chance of occurring, which is why it's not really that rare. And why one of the reasons a long time ago, Congress should have told FEMA to start providing other hazard levels and to quit thinking of that as an upper cap or an artificial ceiling on flooding. It is not only a problem within the flood insurance and the mapping, it's also an issue in the regulation of floodplain development. Developers are told, just be careful you don't modify the 100-year flood. Well, over 30 years, if they stay just underneath that 100-year flood, developers all across the area have impacted flooding. Yes, the 100-year represents a target to try to not impact, but it's not even that an extreme flood to be using as a regulatory threshold. So, or telling people in new developments you should build all the houses high enough so they're up above the 100-year flood elevation. Sounds reasonable, sounds pretty extreme. Oh, your property ought to be pretty secure. Well, no, it's not that extreme a level. But it's become a convenient target, and it was something everybody could buy into using. But after quite a bit of time, 50 years since the National Flood Insurance Program passed, now we have a lot of infrastructure, a lot of homes, a lot of development, a lot of people that are exposed and have been exposed and experience flooding, and they're just totally consistent with the way it was designed. The 100-year flood is not that extreme an event. Think of it this way: if you had a 1 in 1,000 annual chance, that sounds remote, right? A 0.1% chance per year. But if it's like 30 years, it's closer to the odds of rolling snake eyes. And over a lifetime, 80 years, we have a 1 in 12 chance of experiencing a 1,000-year flood. And that's greater than a major house fire. So even when I say things like a 1,000-year flood, you think, oh, well, that's never going to happen. That's never going to happen. Over an 80-year period, you have a 1 in 12 chance of experiencing a 1,000-year flood. That's not that remote. When you start thinking about other factors that increase that are independent exposure, let's say you came from a large family of 10 siblings or 12 siblings, right? and you all live in a different part of the country, and you all live for 80 years. Well, now you're talking about somebody probably has a good chance of experiencing a 1,000-year flood because you've spread. Now everybody is doing independent exposure. If any of you own homes, a rental property in different parts of a city, for example, let's say you own 3 different rental properties in different parts of Baton Rouge, you've got 3 different flash flood exposures. You know, if I'm a regional planner working for a regional agency looking at flooding, I'm not looking at the location specific probability, which are these probabilities we were talking about are location specific, the 100-year flood, 1% at that location. If I'm in charge of planning and worrying about risk over all of East Baton Rouge Parish, you know, there's a lot of potential variations in exposure and in what we call independent exposures. You know, as a governor for the state of Louisiana, if I'm in the office for 8 years, I'm going to see a 100-year flood somewhere in the state because there's all these independent exposures. There's coastal exposures, there's flash flood exposures, there's river exposures, and there's independent location exposures. Just because there's a flood on the Calcasieu River doesn't preclude a flood on the Ouachita River. So, you know, as a manager of flooding, you know, I talk to politicians sometimes, they're stunned to think of it this way. They would think, oh, there's only a 100-year flood. I mean, we shouldn't have any 100-year floods in Louisiana. You're probably going to have at least a good shot at a 100-year flood somewhere in Louisiana within a governor's term, and particularly over a 2-year term. So those are all things to understand about flooding. Sometimes planners and other people will use other shorthands to talk about hazard. They'll use a worst case flood, or they'll talk about a particular flood of record like 2016, or before that it was 1983. Those are all shorthand ways to convey particular anecdotal information about flooding. As hydrologists, we always come back to this idea of a curve. And this curve is location specific. It's a full spectrum of probabilities, not the 1% spectrum or 1 in 100-year frequency. It's all the potential frequencies. Remember, it's a scientific guesstimate. And remember also that the best way to understand these individual values is not as a 1-year probability, but as if your particular exposure is typically a multi-decadal exposure, you got to think of these exposure hazards as cumulative exposures. You know, so you're thinking about exposures that over a 30-year period, it's a 1 in 4 exposure. So that's what the nature of hazard is, and that's what this second one is. I'm going to do a couple more slideshows, and then I want to make sure we have some time for questions. So I've got to close this one out and open up my Explorer again. And go back to my screen share. Oh, why did you close? Oh.
We see the fisherman. Is that what we're supposed to see?
Let's try that again.
Oh, that's your home screen. I see.
Yeah, let's try that again. Sometimes I click too fast. Let's see. I'm not seeing on the bottom of this thing a thing where I can share. Are you seeing my screen?
Yes, we got it now. Flood risk is a present value.
Okay, hazard is the potential for a particular flood level. I told you before, we're talking about risk with a dollar sign. In our case, risk basically is the probability of consequences. We could talk about the consequences of fatalities or the consequences of PTSD or health costs or different things. We're talking about usually in our business, we're talking about direct financial consequences of flooding, meaning damages and other costs associated with taking a piece of property or an asset and getting it back into functional use. So the asset could be a park, It could be a playground. It could be a school gymnasium. It could be your piece of infrastructure like a wastewater treatment plant or your home, an apartment. It could be the swimming pool outside your home. All of those things that have monetary value are assets, even sometimes ecosystem habitats that are used particularly in, they have recreational or fisheries have commercial value. They have ways of pricing those assets. Any diminished pricing in the asset associated with its loss of being out of function, you would call that the cost to bring it back into function. You would call that the dollar value of the risk. What we do basically is we take the hazard curve and we convert it with a value of the cost at each of the depths associated with the damage, and we convert it to a cost. And that is a cost curve or a risk curve. And the key thing about a risk curve is that what you can do is there's a technique, those of you who had a little bit of math in the background, is you can figure out what's called the expected annual cost of the risk for that asset. Expected annual cost is abbreviated EAC. And the expected annual cost is basically, assume I'm talking about a house. And you could think of it in your mind this way. If I had a particular house, if there were 1,000 or 1,000,000 parallel universes, or if there were somewhere on Earth 1,000 or let's say just a big number, like 10,000, 100,000 of these houses in different parts of the world that were identical with identical exposure profiles, what would be the average total payout for risk per year per house? Some are going to go years without. Somebody's going to get the 1,000-year flood that year. Somebody's going to get a 200-year. Somebody's going to get a 20-year. What's the average? We do that in mathematically by doing something called integrating underneath the curve. So you can figure out for any risk curve for any asset or property, once you know the hazards, the property-specific hazard for that curve, and you know what we call as fragility, meaning the relationship between depth of flooding at that structure and how much the cost is going to be associated with that depth, you can come up with an expected annual cost. This is nothing new. This has been done for hundreds of years by insurance companies and people called actuarialists and people who do this for big companies to assess potential risks associated with property. It's done on Wall Street all the time when they're doing big financial deals and they're valuing different kinds of risk associated with a financial deal. It's basically done for us for fire hazards through our property insurance. We don't have to go through all of this. We just use the cost of insurance as a proxy for it because it's been around for so long. Same thing for wind. It's been done, it's been calculated, it's known, there's an insurance policy for it. It's not perfect, insurance companies aren't perfect, but the general process of figuring out what your expected annual cost for various kinds of property damage that you can carry insurance for are in your insurance policy. The problem was there was no way to come up with these curves and do these calculations for flood risks. So that's why for decades and decades, and we're not in the position today of being able to use our flood insurance rates as a proxy for our flood risk. But that's the way it's done for all these other risks. The other interesting thing that we should understand about calculating expected annual costs is that when you are going to pay that expected annual cost year after year, you can figure out what economists call or financial advisors call the present value of that. How much would you have to put in a bank today and be able to take something out if that amount's earning interest and pay it out every year in order to cover that expense? That way, if you had two houses and you knew this house had, for whatever reason, had a lot higher property insurance because of the nature of its otherwise identical, but this one for some reason had a higher maintenance cost, or in this case, a higher insurance cost. Let's say it costs $1,000 more to buy this house versus this house, and for every other value they were identical. That house would cost something less to buy because it costs $1,000 a year more to insure or maintain. It's just like going out and buying a new house and looking at one that needs a new roof versus one that doesn't. It's got an expense associated with it. This one doesn't, therefore it's worth less. We call that present value. And for any expense, you can figure out what its present value is, meaning how much would you have to put in the bank today to figure out down the road and pay for that extra cost. Flood risk is no different from any of the other risks historically that have been dealt with financially through this analysis. It just hasn't been done traditionally because you haven't had access to the tools to do it. But does that mean that's not the real way to analyze flood risk? No. And the part of the presentation I said I really wasn't going to have enough time to get into is why we're going to be in the position where everything's going to change and we are going to have to be aware of financial flood risk and understanding what the present value of it is. The key in this video is this tenet is that flood risk is really a dollar number, and it will affect the value of every asset. Within 10 years, I guarantee you, every house in the United States, this property value on Zillow. How many of y'all have ever looked at Zillow and looked at the value of your house on Zillow or Realtor.com? It's going to be affected just as if you were selling your house and it needed a new roof, or the air conditioner was old and it needed a new air conditioner. If it has a differential flood risk in terms of the expected annual cost of flooding for that house, that number is going to be around within 10 years on every piece of property. It's not really reflected well in the new risk rating system, and we can talk about that during your questions if some of y'all have questions about the new FEMA risk rating. It's going to come from the fact that there are people in my profession who are going to provide property-specific hazard curves, and based on the nature of the information on your property that's available on Zillow, estimates of your depth damage and estimates of where the elevation of your house is. And based on those things, somebody's going to be pricing the risk on your house and publishing it. And Louisiana is going to have that happen all over the state, and it's going to happen in every state. It's already happening in the commercial world, and it's happening to the degree because commercial loans, basically, bankers are looking at these commercial loans and say, I got to have this property is being used as security for this loan. I got to have it insured. In the world of our residential property, bankers and mortgage underwriters are still of the mindset, well, if it's in this zone, you got to get it. If it's not in this zone, you don't have to get it. And so they kind of look to the federal government to the extent that mortgages are insured by the federal government, and there's these other financial safety nets, that they don't really have to look at an individual house by house. I can tell you that's going to be going away. Number one, it's going to go away because nobody has faith that that's going to be around for a long term. So if your child was buying a house tomorrow, you would advise them to figure out what kind of flood risk is. Even if they say, well, mom, I can get flood insurance real cheap from the net. Maybe not in 10 years, you won't. And if it has a substantially higher flood risk, you want to know about it before you buy that house. So regardless of whether flood insurance continues to be subsidized or, in somebody's language, affordable, people want to know what the real flood risk is, and it's a present value number, the same way it is for other types of expenses associated with assets. So I'll do one more of these, and then we can open some things up to some questions. One of the ones I'm going to skip is, points out two things that are a consequence of this financial wake-up call about flood risk. Yeah, I'm in the wrong folder. I'm going to do the one on wise policies and skip the others in the interest of time, because I think you guys might be interested in some of the policy things. In the other videos, I make the points that, I was talking about buying and selling a property or helping your child buy a property. There's a term of art, a legal term with force that's used. Those of you who had an experience dealing with transactions, particularly property transactions, or bought and sold businesses, or know people who buy and sell businesses. Maybe you've bought some investment property or something like that. The term is due diligence. And under the term due diligence, the buyer is responsible, like buyer beware. Anything that he should probably be able to figure out and know and understand, he better. And he can't use that as a defense against fraud. You know, he can't accuse the owner of fraud if he was really in a position to go out and find out something on his own and figure it out. It is within the commercial world, it is rapidly becoming the legal standard of practice that you have to figure out what the price of your flood risk is. I mean, you can't just say, whoa, you know, I bought this strip mall and now it flooded and it was outside of the flood zone and I didn't have it properly insured. You know, that's not a good legal defense. You know, the flood zone is just an indicator, and a lot of times the maps are old and it doesn't portray all the levels of risk. It only shows one risk. You know, it's to the point that the commercial property world, any big time investment world, and the bankers that finance these deals are all requiring a high level of due diligence. That standard of due diligence cannot be that different with residential property for that long, because there's too much investment money coming right now into residential property. There's actually, Zillow is in the business of buying homes right now. So, and mortgages are bundled and sold as financial instruments all around the world. And these buyers of these instruments want to know if there's flood risk associated with some of these loans and if it's insured. So there just cannot be this world in which we stick our head in the sand and say, we don't really care that much about what the flood risk is because we got the National Flood Insurance Program, when the NFIP is so broken and obsolete. So the world of flood risk due diligence is a big issue. I try to tell people, yeah, you talk to government people all the time, and in their world and their tunnel vision, a lot of it is, what can the government do about flooding? People are tired of it. They're yelling and screaming at their representatives. The representatives are screaming at the bureaucrats, and everybody's saying, we got to go do something about flood risk. When in fact, there's this other private sector action going on, and it's going to continue to go on, which is you need to know your flood risk, and you need to be able to make good decisions as a stakeholder. And those of us who are stakeholders and require loans in order to have property, that's going to be the big issue in the next 5 to 10 years. Is the bankers are basically going to end up driving more and more due diligence as well. The other aspect about financially is insuring a risk is always the first way you look at trying to manage your risk. You don't go out and necessarily ask the government to put a fire hydrant in front of every home, although that would reduce the risk. We put fire hydrants in front of homes basically to control the cost of flood insurance. And yes, it saves lives and everything, but obviously you have a smoke detector in your house to primarily save lives, and you evacuate. Just like evacuation is the primary way we address the risk of flooding for public safety. But there's always a trade-off point at which you invest in mitigation versus will it continue to be cost effective to do more. You wouldn't go out and spend the money to put a fire hydrant in front of your home if you couldn't reduce the cost of your property insurance enough to do it. And that's traditionally where communities go in for bonds and upgrade their fire systems and water systems in rural areas as they get more and more people coming in and subdivisions get built, is because you can reduce the cost of your property insurance if you invest in better fire protection systems in the area. So insurance is the first way to go about reducing and managing your costs. And then you wouldn't mitigate a risk if it's cheaper to insure it. And that's part of our public mitigation problem right now, is we don't have our arms around, and all of our property owners, all of our citizens don't have their arms and heads around what their real flood risk is, and whether there's anything that can really be done that's cost effective in terms of reducing the cost of insurance. But we're going to be confronted with that as a society and as communities in the next 10 years, because this information on your flood risk is going to come out, and people are going to start saying, well, hey, my flood risk is pretty cheap. And they're going to actually look at it and say, well, really, my flood risk is only $100 a year. How come I have to pay FEMA $600 a year or $800 a year for a policy? They're going to pick up the phone and call the insurance commissioner and start screaming and yelling and saying, I want cheaper flood insurance. And they'll probably one day, the gates will come open and State Farm will be willing to charge you $200 a year if your risk is only $100 a year. And so a lot of people that don't have a lot of flood risk will be happy. And those that do have an extreme amount of flood risk, if they can afford it, they have a big expensive house on the beach. Well, what's another $1,000 a year to live on the beach, or $2,000 or $3,000 a year to live on the beach? There are unfortunately going to be middle class people and working class folks that live in marginal areas that are going to wake up to the fact that they thought they had $700 a year of FEMA flood insured risk. And the private market and FEMA's markets are going to end up driving them to say, no, you have $3,000, $4,000 a year worth of flood risk. And that's going to have an impact on their property. They're going to look for somebody to mitigate that risk for them. And the public as a whole is going to have to decide, do we want to pay to mitigate that risk? Well, people who only have $100 a year of flood risk may not be willing to pay much for taxes for mitigation. And so there are going to be disparate impacts. Some of them are going to be equity related issues because there's people who live in areas because in the past they were discriminated against. So we're going to be wrestling with the equity issues and racial justice issues associated with flood risk exposure for a while, because these issues are going to get shaken out. And it's going to come into clearer focus as we see what the real flood risk is in terms of these cost numbers and how it really affects property values. So insurance is going to become critical. Within 10 years, nobody's going to get a loan for anything that's property secured without having flood insurance. And hopefully the insurance business will be modernized and improved to the point that your insurance rate will be a reasonable proxy for your flood risk, just like it is for your fire and wind risk. Let's touch on a few other policy related issues, and then I'll take some questions. I guess one other point, you hear the word resiliency thrown around a lot nowadays. It's a good buzzword along with sustainability. In terms of this dollar flood risk issue, resiliency basically means you have the ability to recover. It's not like you can be promised that you'll never flood. In fact, the word protection should never be used with flooding. Protection comes from when we design systems like the Mississippi River Levee to protect people's lives. And it has the connotation of this binary that if you're protected, you have no risk. And if you have no risk, well, why the hell would you need insurance? You don't need risk, I'm protected. We should never even use the word protected when we're talking about flood risk. We should use the word risk reduction or mitigation. In fact, after Katrina, there was such a hue and cry over the failures of the system around New Orleans that the Corps said, okay, we need to be upfront with everybody. This is not a protection system. It's now officially never called a hurricane protection system anymore. Its name is a hurricane and storm risk reduction system, meaning it's only there to reduce the cost of your flood insurance. If a big enough storm comes along, and remember, a 100-year storm isn't that rare, and New Orleans as a system has multiple independent exposures. So it's not like the whole system is good for anywhere around the whole system. It would only be overtop at a frequency of once every 100 years. It's independent exposure. So there's actually some higher chances for somewhere it being overtop. But again, it's there in the context of a FEMA threshold, to be designed for that FEMA threshold of the 1 in 100 year. And it's not there for anything to protect any public safety. It has, if a small storm comes along, like Ida was actually relatively small in terms of a surge generating. Gustav was a worse surge generating storm than Ida was. Yeah, it's going to keep the surge out. It's going to perform, but it's not like that is a big stressor hurricane surge event for that system. But it's only there to mitigate or reduce, and it's there to work in conjunction with flood insurance. If government actually goes in and does a mitigation project to reduce the cost of flood insurance, but the community doesn't get the flood insurance, well, how did it really end up mitigating the risk? Again, the mitigation is there to lower the cost of insurance. Insurance is the way you get resiliency. And I guess Wall Street is looking closely at this in terms of a lot of communities now to see whether or not they want to loan a community money for a new school or for a new water system or to build the libraries or to do other projects, because those citizens have to pay back the bond. And if those citizens aren't carrying flood insurance on their homes, well, how resilient is the community? So again, the financial understanding of flood risk and understanding how important insuring flood risk is to resiliency are two of the real keys to understanding where flood risk management is going. And then mitigation is like mitigation of fire risk. You do the investments in flood risk mitigation in order to control the cost of flood insurance. So wise policies for the future include adopting these tenets and having all of our folks involved with policies at various agencies understanding these important tenets. Obviously, we don't want people promulgating foolish ideas like that flood risk is a binary, nor do we want them to continue to promote the idea and sense that this 100-year exposure represents a really worst case that people should be designing for. It's a threshold that is really a moderate level flood risk. It is not an extreme flood risk, and it should not be used as a threshold anymore or an artificial ceiling. The NFIP information is so old and obsolete, it doesn't support due diligence. And because it actually discourages some people from having insurance and being underinsured, it's not even support. It's so antiquated, it's actually done the reverse of making us less risky. The NFIP has actually perversely made us more risky and exposed to flood risk. In the future, we want our government to facilitate modernizing the state of the practice so that we can have due diligence. If we want our government to do anything right now, we want it to help hurry up and accelerate our ability to define our expected annual cost of flooding and our present value for our house. We don't want somebody else populating numbers on Zillow for our houses that are wrong for our flood risk. When that number starts to pop up on Zillow in 5 to 10 years or wherever it's going to pop up, we need it to be reasonably and good. And in order to do that, that information is going to have to be out there. So whoever these number crunches are that are going to populate that information, we don't want bogus information. It's just as bad to overprice risk as it is to underprice. And I'll tell you from the perspective of New Orleans, I have family that live in New Orleans, and I did a lot of work around New Orleans, and I talk about the perimeter system. The perimeter system is actually better than a 1 in a 100-year system. And there's a lot of value in property in New Orleans. And personally, I think New Orleans is an extremely viable place to invest in property. Some parts of New Orleans I wouldn't invest in, but a lot of parts would be fine. And $1,000 a year worth of expected annual cost, or even $2,000 a year worth of expected annual cost, if the property is making is a good investment from the standpoint of it's a good restaurant location, or you want to live there and you have a job down there and it's a good job and you like living there, $2,000 a year worth of flood risk compared to the cost of air conditioning and other things that we recognize as just a cost of living in Louisiana. Got to have air conditioning. Well, the cost of living in New Orleans might be $2,000, $3,000 a year of flood insurance. But we don't want somebody to come along and say it's $10,000 a year worth of cost, or that New Orleans just needs to go away. You know, people need to abandon New Orleans. A lot of these areas are going to be more expensive to live in, but that doesn't mean that people aren't going to choose to live in them. It's just like air conditioning, as I said. So there's a lot of opportunity for government to get in and make sure that as we move to an era where we have more detailed and accurate flood risk pricing, that it's fair and that it's accurate. Insurance market is someplace where there's a lot of potential for shenanigans. At one point in time, I think we had like 2 or 3 insurance commissioners in a row go to jail. You know, to the extent that we have to insure flood risk to be resilient, and to the extent that people are using flood insurance as a proxy for how much risk is there, that needs to be rationalized, and there needs to be good flood risk insurance capability. Eventually, that means having private sector companies coming in. They need to be sound so that when they do have claims, they can pay the claims, and they need to be fair, and they need to be actuarially accurate. And the other thing government can do is it can do a lot to stimulate and encourage, and eventually the federal government can say any mortgage needs to have flood insurance, and it basically should. And if your risk is $50 a year, well, then you should get it as a rider on your insurance policy. Good for you. One last point, and I'll skip on other points because I think my friend Doug Daigle is on the call. One of the things that comes up a lot in flood risk management now is the idea of green infrastructure and other important goals for floodplains: restoring floodplains, preserving floodplain habitat, preserving floodplain ecologies and ecosystems. These are all valuable goals and important goals. And to the extent that we want to do 2 or 3 things and kill 2 birds with 1 stone, I mean, sometimes that makes a lot of sense. But sometimes there's a tendency, and because you guys are naturalists, I'll really pass this point on to you guys. A lot of times conflating objectives results in suboptimal programs or suboptimal projects for both of the goals. And I'll give you a case, an example. If you take coastal restoration, for example, and you talk about restoring wetlands, and the restoring the wetlands is going to be a speed bump and reduce hurricane surge and protect the city of New Orleans. Qualitatively, that's all true. But quantitatively, when you begin to parse that out and say, if you have a home in New Orleans and you want to reduce the cost of your flood insurance, and there's $1 million, and you want to pay money to save money on your flood insurance, and you're going to pay that money in taxes in order to reduce the cost of your flood insurance, there is no coastal restoration project that's going to be done that will reduce there's no flood insurance. There's very few aside from maybe doing some vegetative planting along the toe of a levee to reduce some scour, which a good friend of mine, Wendell Curall, has done down in South Lafourche. There's very few coastal restoration projects that will pay for themselves in terms of the cost of flood insurance. So if you're asking and selling a project or a program to the public and say, this is going to reduce the cost of, this is going to reduce flood risk. If you're really talking financial flood risk, you have to be very careful. And similarly, if you take a project that you're going to invest in and say it's going to also improve habitat, maybe the thing that you're building might do a little bit of work on surge, but hardly not. But it may not be the best way to improve habitat. So if you have habitat goals and you have some dollars for habitat goals, go and get your best habitat. If you have a flood risk reduction goal and you have a pot of money that's dedicated to flood risk reduction, then go do flood risk reduction with that. If you begin to mix those goals together, you're going to have a real problem, not necessarily because it's a conflict of interest, because yeah, to some extent they are reinforcing. The problem is, will you get the best habitat and the best flood risk reduction that you could get? In some cases, you're not going to do that. Like I said, the big push right now is for green infrastructure, which has a lot of aesthetic, a lot of recreational values. It has a lot of other values associated with cultural values. There should be an interest in doing it. The people that are interested in doing a lot of green infrastructure want to tap into flood mitigation dollars to do that work. But if it doesn't really significantly reduce the flood risk, and there are other ways to get more bang for the buck out of flood risk mitigation dollars, then I'm sorry, you shouldn't be using it to invest in that. Similarly, if you're trying to preserve floodplains, maybe there's a reason to preserve floodplains and preserve floodplain habitat. You'll hear the idea that floodplains are sponges and they soak up and they do all of this. And qualitatively, a lot of detention that floodplains produce is important. When you actually look at how you're going to reduce the cost of flooding in an area, or to people who are already there by controlling further development or imposing restrictions on development, and ask, do those restrictions on development really reduce the cost of flooding? It's like if you live in a subdivision, you build your house in the subdivision, you have empty lots all around you. And for 2 or 3 years, nobody builds next to you, but then all of a sudden people are building next to you left and right. That's increasing your fire risk. You know, you're going to go out and have a public hearing and say, don't anybody build next to me. I don't want to have my fire risk increased. Chances are it is increasing your fire risk a little bit more to have a house built right next door to you rather than having a vacant lot. But your insurance doesn't go up because of it. So you don't have a dollar flood risk. You have a slight higher qualitative, but you don't have the dollar flood risk. Our focus on regulating development needs to figure out exactly where we're going to preserve flood insurance costs for people, and where, because we're telling somebody what to do with their property that maybe we wouldn't be willing to do with our own. Like, are we willing to go out and dig up our driveways and put gravel in? But we want somebody else to do it with their driveway. Because we're trying to tell somebody else what to do with their property, we ought to be pretty clear that it has a specific dollar benefit to the public that we can then impose that value on public. So I'll leave it at that, these things are important. And qualitatively, a lot of times things like, oh, coastal restoration is going to reduce flood risk, qualitatively sounds true. When you get to actually parsing the dollars out, though, if you are exposed to significant flood risk and significant cost for your flood insurance, and you're going to spend money to reduce the cost of your flood insurance, you want a project, dollars spent on that project to reduce the cost of the flood insurance. And similarly, if you want the habitat improved, you want the best habitat improvement project you can get. And so sometimes mixing goals, while it sounds good, doesn't always produce really a good result. And with that, I know there's going to be lots of different questions about actual flood risk, flood hazards in locations and areas, and maybe some of these policy questions.
Thank you, Bob. I'll just ask our participants here if you just want to try to jump in one at a time and unmute yourself and ask any questions if you have some. Or if you feel more comfortable, I'll also monitor the chat.
Yeah, did we have anything come up on chat? I didn't see anything on chat. Come on, this has got to be controversial or something.
To what extent does emptying your ditch of weeds and detritus improve your flood risk situation?
Yeah, I think that's a really good question, because there's a big discussion of doing snagging work, which for those of you who don't know, the term snagging is also equivalent to desnagging of different streams around the Baton Rouge area right now, and that's often comes up. You know, when it comes to flash flooding, having your drainage system functional as it's supposed to be designed is a critical issue for the guy who's got the lowest house in the subdivision.
Right.
It may not be important to you if you're the highest house in the subdivision, but the guy who's at the lowest part, like one of my friends, it's real important to them. But you can even be at the high end of a subdivision, and this happens in sewage areas all the time, where you get sewage back out, even if you're at the highest end, because if the system isn't carrying out the water. Keep in mind, it's really important to understand drainage. There's a whole history issue with drainage. Drainage is traditionally, when government didn't have the ability to work with the insurance industry to figure out how to invest in mitigation like it did with fire and wind risk, and going back to before World War II, they were effectively working with the insurance industry to figure out how to have government impose standards to improve building practices and infrastructure in order to control insurance costs. Because that didn't happen in the world of flood risk, government's involvement in flood risk bifurcated into two things: flood protection, which is to save lives, and drainage, which was just do something practical, And consequently, drainage evolved around the idea of roads and transportation before World War II, building lots of roads and making sure the roads were normally open. And so all the standards relating to roads, one day when they finally started putting flood hazard numbers to things, they realized that they were designing things for 1 in 10 year storms, or maybe 1 in 25 year storms. And so again, it was really critical not to be the low end guy in the area. Back in the 1940s and 50s, when we were a more rural society, people understood these things because they came off of farms. They were probably one generation away from living out on a farm or something. People understood that, and they built their houses on piers. Starting in the 50s and 60s, when we went to dominantly building slab on grade, and a lot of people were moving from the urban areas out to the suburbs, people didn't understand about drainage and the limitations of drainage design. And of course, nowadays, we're really seeing that over the accumulation of time. I mean, how many times does a 1 in a 25 or 30 year storm hit over 60 years? And, if you have enough subdivisions around an area, some of them get hit by 2 or 3 times. And then if the systems aren't even maintained, or again, there's uncertainty around these numbers. Maybe what they designed for 1 in 10 was really a 1 in 5, Consequently, drainage is an extremely limited infrastructure to depend upon, particularly when thinking that you might have exposures to these more extreme storms. Clearing out the drainage infrastructure, meaning the ditches, or particularly if there's subsurface areas like in New Orleans, you have the catch basins that are filled up with Mardi Gras beads and all that kind of stuff, or in your neighborhood, maybe there's leaves that are blown into it. Keeping the drainage infrastructure clean is really critical for the poor guy on the street who has the lowest house on the street. Once you start getting into the major streams, like in Baton Rouge area, we had some pretty intense rainfalls back in May, but it wasn't that intense in some of the rivers. But once you get into areas where you have major river flooding, one thing people don't appreciate a lot is in a major river flood, where those floods are way out of bank and the floodplain extends for thousands of feet or yards on either side, you know, the conveyance that's happening in the actual channel is very small. So how much you might go in and improve a channel and clean out a channel for some of these big floods, that's not really going to impact the flood risk at all. The main thing that we do sometimes that impacts flood risk, and this goes back to the drainage designs of roads in the 20s and 30s, is that we build roads right across floodplains and put small little openings where there's bridges. And we started doing that in the 20s, 30s, and 40s. And we began altering the way flood goes down a floodplain, and we created these constrictions of these bridges. And so a lot of times what we see in the major floods, like we saw in 2016, and a classic example is the barrier on 12, is you see infrastructure, roads, and the bridge openings causing backing up of flooding. And that just goes way back to the 20s and 30s when we started building a bunch of roads, and we said, we can't afford to build huge openings and long bridges every time we cross the stream. We need roads. So, you know, we were okay with having small openings. But cleaning out ditches, or just in general, maintaining drainage as a local responsibility, it's tough to get the taxes for it, because again, it's only the guy who's got the low house on the street who gets flooded. You know, my wife says, hey, it ought to be the subdivision's responsibility. The subdivision ought to have clean out ditches day or something like that. Anyway, that's a very big, important challenge, is maintaining drainage. And in a lot of cases, what people think is good drainage, you know, I haven't talked a lot about climate change. We know that our rainfall frequency estimates are low, given what we understand is going on in the climate. We can look over at Houston and see where they've actually done some recalculation of numbers. And we know that things that have traditionally been thought of as a 10-year or a 20-year rainfall event are probably have twice the level of return based upon what is a more current estimate of those rainfall frequencies. So when you look at the capacity of all the drainage infrastructure to handle storms, it's going to be
flood control.
Okay. Who's meeting about flood control?
Let's see, there was another question, Bob, in the chat from Doug Daigle about East Baton Rouge Parish adequately assessing those issues in its development decisions. Are we doing a good job?
Well, I think where we're going to go again is over the next 10 years, things are going to change in terms of everybody kind of having a picture of what their flood risk is in a dollar value. And you know, on one hand, you'll have subdivisions which have some exposure. Like a good example might be Walden in Baton Rouge. And there's a picture I have somewhere. The guy just paid an astronomical amount to elevate his house on his own because his house flooded. And so you'll have those kind of subdivisions where people will wake up and see they have exposure. You'll have other areas which are disadvantaged neighborhoods where people are there because historically they couldn't buy in other places and they have property in those areas. They're going to be disadvantaged. And I think you're going to see once things crystallize around what people's dollar exposure is to flood risk, what they're going to end up in the long term paying for flood insurance and how it affects their value, you're going to start to see the policy come around to that. Right now, too much of our policy is driven by this artificial ceiling of the 100-year. Everybody argues, and like the big thing that came in the paper, we're going to have a moratorium and we're going to do this and that. It's so twisted around. Well, number one, somebody can take credit for maybe shifting the needle a little bit in terms of the level of review. Or I think one of the things that happened was the developers were asked to put a little bit more detention capacity. And so they were able to tweak something enough. You know, when the developer basically agrees with what's proposed and says, I'll go do that, no problem. I mean, how much of a burden was it? Probably not a lot of a burden, you know. The real crux of the issue with the development, in particularly like along areas of Burbank, is what is going on to the cost of flood insurance for those areas around there, because there's a lot of when the flood insurance numbers really start to be rectified down in this Burbank area, for those of you in the Baton Rouge area, you know the area I'm talking about. Once all these subdivisions, people start seeing they're going to have $3,000 or $4,000, $5,000 worth a year flood insurance, it really isn't the next development that's going to change that. There might be some areas and where it will have an impact. Then there's going to be a hue and cry, whether it's a bridge opening, which I think again goes back to the bigger issue. Nobody has asked DOTD in redoing the Airline Highway Bridge or the Interstate 10 bridge, or eventually the Jefferson Bridge, or the railroad company that redid their bridge through the Santa Maria subdivision, how all those bridges are affecting the flood elevations in the Bayou Manchac watershed. Those are so much more significant than the increment of an additional development on somebody else's existing property in that area. But there are cases where development can affect that. The other aspect of regulating buildings and activity to reduce flood risk comes in the area of detention and requiring more detention in the areas where the water is coming from and running off. So, for example, I live in parts of Kenilworth where I don't really have flood exposure, but obviously my water is going downhill to somebody. At some point, what we're going to see is everybody's, and they do this in some communities. I think Austin, Texas has been doing it for a while. They tax you for your runoff. You want to have pavement and hard surfaces and you want to let water run off, well, then you're going to get taxed for it. Otherwise, you need to go in and come up with a way of putting in some green infrastructure, taking up your concrete and putting in a porous pavement or something like that. Or particularly doing it with new development. In some ways, it's easier to regulate new development and we can impose burdens on new development that we don't impose on existing development. But at some point, you have to go to the existing development and ask them to bear their fair share. And so, if we're going to get to the point where in order to really do an economical reduction of flood risk in a region, and we're going to ask everybody to do something to help, we're going to have to go to everybody and say, consider tearing up your driveway and putting in a porous pavement, a porous driveway. That's going to be the issue that's going to be fair. It's going to have to be driven by reducing people's cost of insurance, though. You can't ask people to do it qualitatively. And you won't be able to, because this issue of priced flood risk is going to come. If people start looking at their price flood risk and say, I'm not concerned about flood risk, I'm not going to pay attention to it, I'm not going to vote for it, I'm not going to worry about it. That's what's going to happen. It's like fire risk. People don't get all upset about their fire risk. They just buy insurance and cover it. I'd like to know more about what everybody thinks when they hear this, because I know a lot of times when I talk to people, we are so used to thinking about flood risk qualitatively, particularly with this binary, because that's the only handle we've grown up with. I'm 65, and for all of my life, it's basically been what most people understand as flood risk. I have it or I don't. And it's qualitative. All of these things that you basically see in the media are driven to a 6th grade level understanding of things. So a lot of times it's qualitative. So when I make these presentations, and as I understand, it's a bit of a drink from the fire hose, as we like to say, to think that this is going to shift revolutionarily to a more financial understanding of flood risk and a more financially based decisions about flood risk. For some people, it goes zoom. And for some people, it really, changes. And for some people, it makes them angry. And, so I'm prepared to hear some feedback from people. Some people think it's great. They think, oh, yeah, that's the way it should have been a long time ago. So I'm really interested in any people who are having some reactions to this.
Well, Bob, this has been most informative. We have learned a lot about floods and insurance and risk. And I think we all feel a little more knowledgeable, maybe a little less secure, but that's reality. And I'm looking at our time and thinking if we have another one quick question, but if you would like me, I could be happy to share your email if anyone would like to get some further information or ask any additional questions.
Sure. My email address and phone contact information should be on the email that I sent you with the links to those things. So
yes, it is. That's right. And everybody got those links. And if they want to, let me remind you, that, you know, you can get great summaries. I don't think, I watched a few of these. I don't think they go in quite as much depth as what you did tonight, but they do, you know, touch upon all the basics. And so I encourage you to use those, and you can get Bob's contact information from there. And we're most appreciative that you spent your time with us this evening, Bob. We thank you.
Again, if there's somebody who would like to push back a little bit, I mean, I'm certainly open to hearing other folks' ideas. Colleen, I see Colleen's on there. So if anybody else has any things and wants to talk offline, give me a call. Or like I said, you have a minute or two more for questions.
Okay, I'm seeing thanks from North Louisiana. And I think everybody got the email links, because I sent them out to both the state board and the Baton Rouge members, so they should have access to those.
Well, share what you've heard tonight with friends and colleagues, and if there's anything interesting that pops up as a result of talking about this. I would have expected maybe somebody here would be all upset because they heard their flood insurance was going to go way up under risk rating 2.0, and we could have talked about how that happened and why that happened. And unfortunately, I'm not a huge fan of risk rating 2.0. I think too many cases it went up way too high. In some cases it didn't go up high enough, and it's not really taking advantage of a lot of the science and information that's out there to do a better job of getting us to where insurance actually reflects true risk. But I would have thought, you know, just because that's been big in the news in the last month, we would have had some people really ready to talk more about the financial. But it's interesting that you got a big group here, and we haven't really stirred it up enough. Maybe everybody's got their dinner.
I was definitely surprised about the $5,000 a year flood insurance figure. That kind of raised my eyebrow.
Was that yours, or you heard about it for a case?
No, you just said up to $5,000 a year in flood insurance a while ago. So
there are instances of somebody finding out, and the way it's going to happen is if you had a policy this summer in place, or before risk rating 2.0 went in place, you have an existing policy. The raises in your policy are capped to 18% a year. But ultimately, if you go online, and I think one of the websites that'll do this is called Neptune, you can plug in a little bit of information, and online you can find out what a new policy on your house probably would go for. And the differential is where your policy is going at 18% an increase a year. That's where you're going to end up at some point. If you try to sell your house tomorrow and somebody has to get a mortgage to buy your house, that new value price is what they're going to have to pay. And unfortunately, if you're the low house on the block and somebody up the block has a higher house and their flood risk is a lot lower, and both your houses go on the market at the same time, and they have, well, you can figure out where I'm going there. It's just like if your house needed the new roof and the other house didn't. It's going to impact the value of property. And the NFIP and people that have been proponents of Risk 2.0, the bureaucrats that are trying to defend it, you know, are spending all their time talking about how most people's policies won't go up. And they're not really coming clean with all of these aspects, particularly on the effects on valuation, nor are they really fessing up that, you know, like a lot of things government does a lot of things well. Sometimes it doesn't do some things well. What it doesn't do well in the case of flood risk is it hasn't taken advantage of all the technology that's ready now to begin telling everybody what their property specific flood risk is. And then let's figure out how to get you some insurance for it as cheaply and efficiently and fairly from somebody, whether it's the federal government or, you know, private companies aren't afraid to write flood insurance if they can cover their risk. So it doesn't matter what the risk is. If they can cover it, they'll insure it. So whoever's going to insure flood risk, let's get everybody properly insured. But yeah, there are cases of somebody's exposure being very high. I have a college roommate. Those of you who know Destrehan area, Ormond Plantation, it's a little low area between the River and Airline Highway, between Laplace, or actually between the Bonnie Carey Spillway and Kenner. It's going down airline highways before you get to the airport. So on your right, it's a bowl, and it's subject to some pretty stout flood risk. He's got flood insurance. He's grandfathered in. Probably pays less than $1,000, but I'm sure if he went on someplace like Neptune and looked at the cost, the future cost, it's going to be in the several thousands of dollars per year. So,
All right. Well, thank you. I appreciate it.
All right, Bob, we thank you, and we will share your contact information, and we are again appreciative. And there's lots of thank yous in the chat. And also, of course, for those of you who are here, you were here, but for those who were not, we do have a recording, and that recording will eventually be on our LMNA YouTube. And Bob, if you'd like access to that, we can do that too.
Perfect. Everybody have a great evening.
Thank you very much.
Thank you. You too, Bob.
Thank you.